Okay guys, so this is the first video for chapter 3, which is all about solving linear inequalities. So let's talk about what an inequality is, okay? And this is the first section in our notes for chapter 3. It's writing and graphing inequalities. So what is an inequality, right? We've got to know that. A mathematical sentence that compares two expressions using inequality symbols. So we're talking about comparing two things, and how we're going to compare them is using these symbols here. We've got 4 different types of symbols, and they look like this. We've got a less than symbol. Guys, we're going to remember the difference between a less than symbol and a greater than symbol, because a less than kind of looks like an L, right? So L less than, it's fewer than. Greater than goes the other way, and it's more than. So for example, we can say like 3 is less than 5, okay? And then here's your greater than symbol. We can say 7 is greater than 2. Another way you want to think about and remember, like just a little trick, is the inequality is always facing the larger number. Or if this is a little alligator mouth, it's eating the larger number. So it says 3 is less than 5 because 5 is the bigger number. 7 is greater than 2, it's eating the 7 because 7 is the greater number. These next two symbols just introduce this bar underneath. So this says it's less than or equal to, or greater than or equal to. So that means is most or no more than, or at least and no less than. So for example, we can say 3 is less than or equal to 3. Right? So it's at most 3, but it's no more than 3. Or 8 is greater than or equal to 5. Right? 8 is greater than 5 or equal to. As we know, it's greater than 5. Okay? Let's check out some more statements. A solution to an inequality can be substituted back into the inequality. It makes a true statement. Okay? So this is when we're going to take a look at some variables pretty soon. Inequalities have infinitely many solutions, called the solution set. This is really important when you go through higher level maths. Infinitely many solutions. What this means, guys, usually when we solve an equation, right, after you do all the work, you're going to get something like x equals 3. Okay? Well, guys, that's just one solution. Now, when we solve an inequality, our answer is going to be x is less than 3, for example. So infinitely many solutions, because x could be, let's write this down, any number less than 3. Versus this one, it's the only solution. So here, the solution could be 2, 1, 0, -1, infinitely many solutions when we have an inequality. So this first example is just practice writing inequalities. So it says a number is fewer than 30. Fewer means less than. So I've got x is less than 30. Here it says a number minus 3 is less than or equal to -2. So I just have a number, x, minus 3, so I subtract 3 from it, is less than or equal to -2. It's really important we can take these words and turn them into an inequality. Number 3 says twice a number, so 2 times a number is no more than -7. So that means it has to be less than -7 if it's no more than. And 5 more than a number is at least 15. So I've got a number, and I'm adding 5 to it because it says 5 more than the number, this is addition, is at least. So that means greater than or equal to 15. At least, think about greater than or equal to. So now when we are going to determine if something's a solution or not, it says decide if -5 is a solution of the inequality. Remember, if something's a solution, it makes the inequality true. So what we're going to do is I'm going to take that -5 and put it in for x. So notice we'll do -5 plus 12 is greater than 7. And then I do -5 plus 12, and that gives me 7. And then I ask myself, is this true? Is 7 greater than 7? And it's not. right? So that's no. What could be true is 7 is greater than or equal to 7. That would be a true statement. And then let's check this out again. Decide if negative 5 is a solution. I'm going to take that negative 5 and put it right in for P. So I'm going to have 1 minus 2 times negative 5 is greater than or equal to negative 9. So I'll do follow order of operations, and I'm going to do negative 2 times negative 5 gives me a positive 10. And then I have the 1 still. 1 plus 10, 11 is greater than or equal to negative 9. Well, that is true. So yes, we could say negative 5 is a solution, because it makes that final inequality true. Is this true? That's what we have to figure out. Is this true? Same thing here. Is this true? And then the last thing we're going to do in this section is practice graphing. So it says a solution set is a set of all solutions that make the inequality true. When we graph these on a number line, there's something there's a notation that we need to be familiar with, whether we do an open circle or whether we do a closed circle. An open circle is when it's just less than or greater than. So that means the number is not a solution. A closed circle is when it's or equal to. So when that line is there, less than or equal to, greater than or equal to, that's when we'll use a closed circle, because that number, it could be a solution. So when we graph these, let's go through a couple of examples. It says x is less than 3. So as soon as I find this number, I'm going to go to 3 on the number line. If it's just less than, I put an open circle. If it was or equal to, I put a closed. And then I have to figure out, well, which direction am I going to shade? X is less than 3. I'm going to shade the direction that is less than 3. That's all of these numbers over here. Another way you can remember is if the inequality is pointing this way, that's the direction of the arrow. See how those are the same? That only works if the variable is first. So let's check out this next one. Y is greater than or equal to negative 4. Or equal to, so I put a closed dot at negative 4. Greater than negative 4, so I'm going to shade all numbers greater than negative 4. The next one is C is greater than 1. I put an open circle on 1 because it's not or equal to. Greater than 1 is all the way to the right. So here's what I was talking about. 0 is greater than or equal to B. So I put my number on my point closed dot on 0 is greater than or equal to B. So this is the largest number, and I'm going to shade all of the numbers smaller than 0. How we do want to rewrite this so the variables first is you just flip everything around. So I'm going to put the B first, I'm going to flip the inequality, and then I'm going to put the 0. And now this symbol, this inequality, matches the arrow again. And then this last these two examples here, guys, we're just going to go from the graph to the inequality. So I start with, you can even just set this up, like put an X and then put the number of the dot. So because it says it's a closed one, I know it's going to be or equal to. And look, here's 9, 12, 15, 18. These numbers are all greater than, so I'm going to put the greater than symbol. Here, I'm going to put an X, and then the dot is at negative 3. It's open, so there won't be an or equal to. And then I check out these numbers, negative 4, negative 5, negative 6. These are all less than negative 3. Okay, so guys, intro into inequalities, that's our first section. Great job.